Hello and welcome back to the Expo Hall floor. We are here at AWS Summit here in Santa Clara. My name is Nick Walsh and I'm a technical evangelist here at AWS. I'm joined by some of my other amazing coworkers, Randall and Robert. What do you all do here?
Also a technical evangelist, basically write a lot of Python.
Same thing, but worse than these two.
Always the humble one, Robert. So yeah, we've got a time slot here to talk a little bit about machine learning at AWS, some of the awesome services and new features that have launched since reInvent. Randall, I know you gave a bit of a talk earlier today on machine learning. How did that go?
Yeah, so I gave a talk earlier today about adding intelligence to applications. So if you think about the way that we like to think about machine learning within AWS is in 3 or 4 tiers. So at the bottom tier, you have infrastructure. You have the compute that you use to run various machine learning workloads. So these are things like the P3 instances, the C5 instances, and the GPUs, and all of this kind of core infrastructure. Even things like elastic inference, which allow you to attach partial GPUs, teraflops of compute between 1 and 32 to individual instances. All of that is kind of at the infrastructure level. One level above that are things like the frameworks, or TensorFlow, or MXNet, or Caffe2, or something of those nature. This is where a lot of machine learning developers will spend their time, is working with those frameworks to develop new models. And then you go one more level up, and you have something that kind of abstracts a lot of that individual framework level stuff away so that you can work on training models that are based on those frameworks. This is called SageMaker, and it's kind of a suite of services in one. You can build your models, you can train your models, you can deploy your models in auto-scaling environments. And that's where machine learning developers spend their time. But not every developer is a machine learning developer. A lot of developers would like to bring machine learning tools to bear on their business problems, on their applications, but they don't want to really learn TensorFlow, or they don't want to learn MXNet. So we have a set of API-driven services that I think Nick's going to demonstrate for us in just a second, where you can, with no knowledge of ML, bring inferences and bring machine learning powered kind of context to a lot of your applications.
Yeah, Randall summarized it really well. Ultimately, developers want to leverage machine learning, but it's a huge barrier to have to learn all of this when we know we could actually bundle these services and features behind APIs, something developers are extremely used to working with. So up here on my laptop, I actually have this nice little platter here of all the different machine learning APIs that we have. There are some in private preview that I don't have, or public preview that I don't have listed here, but let's just dive into one of them, right? So Poly is always an extremely fun example. First thing you think of when you think of Poly is like a parrot, right? So it's going to take text that we enter, we send that over the API, and it's actually going to return that as audio. Super valuable for a lot of different things. So let's give it an example. So Robert, or this one is funny. Randall loves coding in JavaScript. So let's see what this returns.
Randall loves coding in JavaScript.
Yeah, so almost instantaneously, that request was fulfilled and returned the audio clip for exactly what we just had. So again, the science behind that, to build that up from scratch on those fundamental building blocks, would take an immense amount of time to be trained in it, specific knowledge. Like, how much of a challenge really is that?
It's incredibly difficult. So synthesizing voice. Does everyone remember that really, really old thing in Windows 98 or something where you could have Clippies say things and it would be, this is Microsoft Sam default voice, and it sounded very robotic? With Poly, you have something like 13 different languages, or 12 different languages and like 36 different voices, and you can synthesize real sounding speech. And the other thing you can do, you can add in SSML, which is an open standard that lets you adjust the cadence of the speech, add in breathing, stuff like that. Because if you listen to us speaking right now, the audio that's getting picked up, you know, the P's and the S and those sounds aren't normally generated by these this text-to-speech synthesis, whereas Poly will go and make these very natural-sounding voices. I do have one request.
Sure.
There's a voice called the Justin voice, and if you've ever seen the Stephen King movie, you remember the clown, and that clown says something along the lines of like, "We all float down here." The Justin voice, if you ever wanted to freak out, everyone in your Is that?
Yeah,
Can
so
we see that?
I actually just popped right over. So this demo is built in React. It's a very standard app, but one of the parameters you can pass to the API is the voice. This is important for a lot of localization regions, making sure that the voice is as authentic as possible. One of the variants is the age of the voice. So I had Brian playing before, but let's see what it sounds like when we use Justin.
Oh boy, this is scary.
What is the?
We all float down here.
We all float down here. All right, Justin. How does that sound?
We all float down here.
Whoa.
The
No,
soundtrack
no.
to Randall's nightmares for years to come. So, yeah, that's Poly in a nutshell. Really, really powerful, but one of just the very many other APIs we have available. So,
And you can also go in the reverse direction, right?
yeah, so there we started with text. We went over to audio, but we can actually do the exact opposite, transcription. We can do this with Amazon Transcribe. So first we're going to start a recording. Robert, I want you to say something over into the computer over here.
You're gonna have to
You're gonna
shout.
have to the room
Oh,
over.
all right, I'm gonna have to come over here. Okay, ready?
Yeah.
We all float down here.
All right. So we recorded it. That recording is going to be uploaded to S3.
We all float down here.
All right, that's Robert's voice
Good
played
pickup.
over the PA, and let's get the transcription.
This one might take a second.
Well, and we get to see how it performs with all that noise in the background at the event.
Yeah,
This
exactly.
Fun story about transcription. The first version of this that we released, it didn't work so well on telephone audio. And the reason for that is telephone operators, network operators, they're incentivized to pack the data as efficiently as possible to minimize the cost of transfer. So what'll happen is you will have, an 8 kilohertz audio stream where in the real world you're hearing, beyond 48 kilohertz audio in your mind, and your brain can do the patch for you between this 8 kilohertz stream with this low fidelity voice, and you can identify the speaker. Whereas machine learning services, they weren't really trained on that sort of data. So we built an 8 kilohertz model for the Transcribe.
Yeah, so the result has now come back, and it says perfectly accurately, we all float down here. So really wonderful. Even with all of the background noise, I know a lot of the mics that we're using have actually done a good job about isolating it, but for my laptop mic, I'd say that Transcribe did a pretty good job there.
One of the other features within Transcribe is that you have speaker idealization. So if you have multi-channel audio like we have here, so we have a couple of different mic channels, we could stream all of those into Transcribe, and it would identify each individual speaker, and it would generate a separate transaction for each one. And the JSON output for that is pretty full-featured. And you can also add in custom dictionaries and
It
stuff
does
like that.
that?
Yeah.
Get out of here.
It also, and
That is so cool.
Yeah, so if you have like a phone call or something and you want to record it, and you can identify which one is speaking.
That's magical. Before we go on though, there was a if we go back to that page in the demo,
Yeah.
so when we were doing the transcribe requests, that took a little while to process. But Randall, you were talking about how this works on a real-time audio stream.
Right. So there are two different APIs.
Yeah.
There's this asynchronous API where you basically start the job,
Yep.
and then there's the real-time API. And the real-time API, right now, I think there's only a Java SDK. I could be wrong on that. We might have released another one, but that SDK will let you take and essentially do, closed captioning or subtitles, in real time, or as close to real time as you can get with, sub 100 millisecond latencies in some cases.
Mm-hmm.
Yeah, and so ultimately it comes down to what is more important for your use case, right? Is extremely low latency for real-time applications, maybe that'll lend itself towards streaming. But we use very short batch processing here, but ultimately you could upload an extremely long, podcast, for example,
Right.
and just automatically transcribe that. And so super powerful, but ultimately a different tool for different problems.
And so, okay, let's say we're transcribing an audio call from a customer, right? Someone calls up my support line, and they were like, Randall Hunt came to my office, and he told me I wasn't using AWS correctly, and it made me really angry, and he's a terrible evangelist. I'm angry.
Completely hypothetical situation.
Completely hypothetical situation. So how do we take that transcription? Let's say we ran transcribe on it, and we had text. Like, what can we do next?
Great question. So one of the biggest values we've seen with these ML APIs is not just using them in isolation, but chaining them together very well, right? So like, let's say, for example, you start with audio, voice, and you transcribe that into text. You can then feed that into another API like Translate to be able to then go from language, audio language in one form and translate it into text of another form. And all of this can just be done with essentially 2 API calls, right? So let's see, we can take any text. I think I have it rigged up now to translate from English to Spanish. So we'll give it something simple. This is nightmare is the theme of this session, it seems.
Why are we doing these Stephen King references?
We all float down here. Let's shoot this over to translate.
I'm not gonna sleep tonight.
Here we go, and that was actually really fast as well.
Yes.
And so one of the benefits to Amazon Translate, sort of under the hood compared to other language modeling methods, is that rather than using statistical models, we actually leverage deep learning to be able to get more contextual insights, right? And so sometimes when you're trying to perform translations, everything doesn't map one-to-one. There aren't direct meanings that can be conveyed. However, there are certain patterns that deep learning algorithms and neural networks can pick up that we leverage under the hood for Translate and pass that on to the customer.
So I'm going to take one quick question from Thor's Lost Kitten, who is asking, is this doing multi-speaker detection on a single channel these days? So it's 2 different features. You can have multi-channel audio, and that will be split into 2 different transcriptions. But you can also do speaker idealization on a single channel, which will identify, you basically pass in the number of speakers that you expect, and it will put each of those things that each speaker says into the right sub-bucket of the transcription. So we've covered Translate, we've covered Transcribe, we've got a lot of the language services done here. What about kind of entity extraction and sentiment analysis for language?
Exactly. When a lot of people think about artificial intelligence or machine learning, they're thinking about generating novel insights that they aren't easily able to really pick up on naturally. So let's look at Comprehend, actually, while we're looking at text passages. So Comprehend is a service that enables any user or developer to be able to detect the sentiment, positive, negative, or neutral, of a given text passage. So we all float down here. I'm curious, maybe negative, maybe neutral? We'll see. So neutral. This is going to return all of those 3 tags that I listed: positive, negative, neutral, or mixed, with the numerical confidence that the model has that is the true sentiment of the text we passed. So lie to me for a second, give me a nice compliment, and we'll see what Comprehend thinks of it.
Nick Wash is a genius, beautiful inventor of a human.
I'd hope I don't invent humans, but let's see what Comprehend thinks.
Did you know that Comprehend takes in emojis?
I did not. How does it weigh that? That's actually a very interesting question.
That was the very first bug that I opened it on Comprehend when it first came out. I was like, hey, I put in a frowny emoji and it told me my sentiment was positive.
Interesting. Yeah, so I mean, irony is, I know, a topic that is difficult for models to detect. Now you're throwing in emojis into the mix. I'd imagine it gets dicey, but maybe at some point down the line, we'll have proper sentiment tagging for emojis.
I think there is already.
Already?
Yeah.
Wow. Okay, so we looked at comprehending sentiment in text, but what is the be-all, end-all for intelligence? I think computer vision, to a lot of different customers, is something that they're pining for already, because there are lots of different use cases.
Before we move on from this demo, if you go back to the Comprehend demo,
yeah,
I just want to point out how cool this is, because we were talking earlier about the different layers of abstraction when we're talking about machine learning, and I know that this field is so new that even as of a couple of years ago, when this stuff didn't exist, what you would have to do if you wanted to build something like this is you needed a lot of data, and then you needed to go and label that data, and you needed to come up and train your own model to make these kinds of predictions. But notice that we didn't do any of that, right? We just kind of cut in line.
One API call.
Yeah, one API call, we cut in line, there's a pre-trained model. We don't even know how it works, but we do know that it's getting better and better over time. So this is just amazing to me. This is like we are living in the future.
Yeah, and I think even if you don't understand machine learning, understanding sort of the confidence value and sort of how it works under the hood goes a long way in developing applications on top of this, right?
Yeah.
Because when you're debugging it, you may not know, exactly the different weights between the neurons on the network under the hood. However, if you understand how close the different sentiments were, you could understand maybe why the model behaved a certain way. And so oftentimes that abstraction is more than enough for developers to have complete control and essentially build the business logic that they want to.
So let's take a quick detour in that route when you said when you're debugging it. But when you've got ML at these different junctures in your architecture, just how do you debug that? What are some best practices there?
Yeah, so as Randall mentioned before, depending on really what level of abstraction you take, that will completely dictate what debugging machine learning looks like to you.
Yeah.
With the API, essentially, you deal only with the inputs and the outputs of the model, and you don't tune really much of it under the hood. But the more control you take, the more foundational building blocks you have, the more freedom you have essentially to tune anything. You can set your own observability, set your own metrics, define your own sort of ways your system will behave under different conditions. But again, that involves a lot of understanding of how to make sense essentially of your model. So it's really a trade-off that depends on what the customer really needs. A lot of times we found that customers don't have a real business use case of customizing a model if there's an off-the-shelf solution that already works. So there's no sense in essentially reinventing the wheel.
Mm-hmm. I'm going to take 2 questions from the stream very quickly. So we have one question from Drugalis __ that says, and a similar question from Hector. They both are asking, can you use foreign terms, and is this just English? What about other languages? So Comprehend supports English, French, German, Italian, Portuguese, and Spanish for text analysis. I think there are other features of Comprehend that you can't quite use in all of those languages yet. But the other thing that you can do, again, is use Translate to get into the language that you need to run Comprehend on.
Yeah, Transcribe recently, actually, within the last month, released support for Korean and German.
Oh, and it had Spanish already.
Yeah. So obviously, we listen to our customers, and that's really what drives where we move next with building support out for globalized languages or different locales for speakers, for example. But we're running low on time, and I really quickly want to show
Let's see the image analysis.
because everyone loves image analysis, computer vision, without needing to know any of it. So I've got my webcam going right here. What we're going to be able to do is take a picture of my webcam, stream those bytes directly to the recognition API, and we're going to be able to get so many different insights. We have only 2 methods we're calling here: detect labels, which is going to detect different objects in the image, and different metadata about their faces in the detect faces API. So I'm going to take a picture.
See if this.
All right, so now that's working.
I'm going to see if it detects the bottle.
So let's unpack this. One API call, and we have all of this. So under the detect labels, we have human, face, person, clothing, all with extremely high confidence values. But importantly, this model doesn't just return a single tag for the entire image. That wouldn't be super valuable. So we have all these different tags. Then on the detect faces side, we have everything from sentiment and emotion of the person to these different binary classifiers, like, is their mouth open? I did that in my picture, and it was very confident. I don't have a mustache or a beard. But you can even get the coordinates on an image of different parts of the face.
And you get bounding boxes for the objects that it detects in another API call.
Yeah, and I know you've used that to build something that's quite exciting on Twitter, right?
Well, we have so much more content to talk about and so many things to show you today, but we want to get you over to some more interviews and hearing more from our expert guests. If there's one thing that you can take away from this, what I want you to know is when you use these API-driven services, the models are improving continuously in the background. So you wake up one morning and all of a sudden it takes less time, costs less, and the accuracy is better. That's a really cool benefit, and you don't need to know anything about machine learning to take advantage of it. We'll be back soon.